MS-DOS is an operating system for x86-based personal computers. It was the most commonly used member of the DOS family of operating systems, and was the main operating system for IBM PC-compatible personal computers during the 1980s to the mid-1990s, until it was gradually superseded by operating systems offering a graphical user interface, in particular by various generations of the Microsoft Windows operating system. MS-DOS grew out of a request placed by IBM in 1981 for an operating system to use in its IBM PC range of personal computers. Microsoft quickly bought the rights to 86DOS from Seattle Computer Products, and began work on modifying it to meet IBM's specification, who licensed and released it as PCA-DOS 1.0 to be used with their PCs in August 1981. Although MS-DOS and PCA-DOS were initially developed in parallel by Microsoft and IBM, years later the two products eventually went their separate ways. During its life, several competing products were released for the x86 platform, and MS-DOS itself would go through 8 versions, until development ceased in 2000. Initially MS-DOS was targeted at Intel 8086 processors running on computer hardware using floppy disks to store and access not only the operating system, but application software and user data as well. Progressive version releases delivered support for other mass storage media in ever greater sizes and formats, along with added feature support for newer processors and rapidly evolving computer architectures. Ultimately it was the key product in Microsoft's growth from a programming languages company to a diverse software development firm, providing the company with essential revenue and marketing resources. It was also the underlying basic operating system on which early versions of Windows ran as a GUI. It is a flexible operating system, and consumes negligible installation space. History. MS-DOS was a renamed form of 86DOS, owned by Seattle Computer Products, written by Tim Patterson. Development of 86DOS took only 6 weeks, as it was basically a clone of Digital Research's CP/M, ported to run on 8086 processors and with 2 notable differences compared to CP/M, an improved disk sector buffering logic and the introduction of FAT12 instead of the CP/M file system. This first version was shipped in August 1980. Microsoft, which needed an operating system for the then-new Intel 8086 but had none available, hired Tim Patterson in May 1981 and bought 86DOS 1.10 for $75,000 in July of the same year. Microsoft kept the version number, but renamed it MS-DOS. They also licensed MS-DOS 1.10/1.14 to IBM, who, in August 1981, offered it as PCA-DOS 1.0 as the default operating system for the IBM 5150, or the IBM PC. Originally MS-DOS was designed to be an OS that could run on any 8086 family computer. Each computer would have its own distinct hardware and its own version of MS-DOS, similar to the situation that existed for CP/M, and with MS-DOS emulating the same solution as CP/M to adapt for different hardware platforms. To this end, MS-DOS was designed with a modular structure with internal device drivers, minimally for primary disk drives and the console, integrated with the kernel unloaded by the bootloader, and installable device drivers for other devices loaded and integrated at boot time. The OEM would use a development kit provided by Microsoft to build a version of MS-DOS with their basic I/O drivers and a standard Microsoft kernel, which they would typically supply on disk to end users along with the hardware. Thus, there were many different versions of MS-DOS for different hardware, and there is a major distinction between an IBM-compatible machine and an MS-DOS compatible machine. Some machines, like the Tandy 2000, were MS-DOS compatible but not IBM compatible, so they could only run software written exclusively for MS-DOS without dependence on the peripheral hardware of the IBM PC architecture. This design would have worked well for compatibility, if application programs had only used MS-DOS services to perform device I/O, and indeed the same design philosophy is embodied in Windows NT. However, in MS-DOS's early days, the greater speed attainable by programs through direct control of hardware was of particular importance, especially for games, which often pushed the limits of their contemporary hardware. Very soon an IBM-compatible architecture became the goal, and before long all 8086 family computers closely emulated IBM's hardware, and only a single version of MS-DOS for a fixed hardware platform was needed for the market. This version is the version of MS-DOS that is discussed here, as the dozens of other OEM versions of MS-DOS were only relevant to the systems they were designed for, and in any case were very similar in function and capability to the same numbered standard version for the IBM PC, with a few notable exceptions. While MS-DOS appeared on PC clones, true IBM computers used PCA-DOS, a rebranded form of MS-DOS. Ironically, the dependence on IBM-compatible hardware caused major problems for the computer industry when the original design had to be changed. For example, the original design could support no more than 640 kilobytes of memory, because IBM's hardware design reserved the address space above this limit for peripheral devices and ROM. Manufacturers had to develop complicated schemes to access additional memory. This limitation would not have been a problem if the original idea of interfacing with hardware through MS-DOS had endured. Also, Microsoft originally described MS-DOS as an operating system for Intel 8086-based microcomputers, and the 8086 CPU itself has only 1 MB of total memory address space. On March 25, 2014, Microsoft made the code to SCP MS-DOS 1.25 and a mixture of Alto's MS-DOS 2.11 and Teal Video PC DOS 2.11 available to the public under the Microsoft Research License Agreement, which make the code source available, but not open source as defined by Open Source Initiative or Free Software Foundation standards. Versions. Microsoft licensed or released versions of MS-DOS under different names like Lifeboat Associate Software Bus 86, also known as SB-DOS, Compact DOS, NCR-DOS or Z-DOS, before it eventually enforced the MS-DOS name for all versions but the IBM one, which was originally called IBM Personal Computer DOS, later shortened to IBM PCA-DOS. The following versions of MS-DOS were released to the public: MS-DOS 1X, version 1.10, a Euro possible basis for IBM's Personal Computer DOS 1.0, version 1.11, a Euro possible basis for IBM's Personal Computer DOS 1.0, version 1.14, a Euro possible basis for IBM's Personal Computer DOS 1.0, version 1.24, a Euro basis for IBM's Personal Computer DOS 1.1. Version 1.25, a Euro basis for non-IBM OEM versions of MS-DOS, including SCP MS-DOS 1.25. Compact DOS 1.12, a compact OEM version of MS-DOS, Zenith Z-DOS 1.19, a Zenith OEM version of MS-DOS. MS-DOS 2X, a Euro support for 10 MB hard disk drives and tree structure filing system, version 2.0, version 2.1, version 2.11, Alto's MS-DOS 2.11, and Alto's OEM version of MS-DOS 2.11 for the ACT86C, Teal Video PC DOS 2.11, and Teal Video OEM version of MS-DOS 2.11. MS-DOS 3X, version 3.0, a Euro support for FAT16. First version to support 5.25-inch, 1.2 MB floppy drives and diskettes. Version 3.1, a Euro support for Microsoft Networks. Version 3.2, first version to support 3.5-inch, 720 KB floppy drives and diskettes. Version 3.21, version 3.22, version 3.25, version 3.3, first version to support 3.5-inch, 1.44 MB floppy drives and diskettes. Version 3.3, version 3.31, a Euro compact MS-DOS 3.31 supports FAT16B and larger drives. Multitasking MS-DOS 4.0 and 4.1, a separate branch of development with additional multitasking features, released between 3.2 and 3.3, and later abandoned. It is unrelated to any later versions, including versions 4.00 and 4.01 listed below. MS-DOS 4X includes a graphical mouse interface. It had many bugs and compatibility issues. Version 4.00, version 4.01 IBM patched version 4.00 before Microsoft released it. First version to introduce volume serial number when formatting hard disks and floppy disks. Version 4.01a. MS-DOS 5X, version 5.0 includes a full-screen editor. A number of bugs required reissue. First version to support 3.5-inch, 2.88 MB floppy drives and diskettes. First version to support partition of hard drives up to 2 GB. AST Premium EXIC DOS 5.0, a version for the AST Premium EXIC series of notebooks with various extensions, including improved load high and extended codepage support. Version 5.0a. With this release, IBM and Microsoft versions diverge. Version 5.0.500 all Windows NT 32-bit versions ship with files from DOS 5.0. MS-DOS XX, version 6.0 online help through QBASIC. Disk compression and antivirus included. Version 6.2 ScanDisk as replacement for CHKDSK. Fix serious bugs in DBLSPACE. Version 6.21 Stacker infringing DBLSPACE removed. Version 6.22 new DRVSPACE compression. MS-DOS 7X, version 7.0 support for VFAT long file names and 32-bit signed integer or level. New editor. JOSIS is an alternative file name of the IOSIS kernel file and used as such for special purposes. JOSIS allows booting from either CD-ROM drive or hard disk. Last version to recognize only the first 8.4 GB of a hard disk. Version 7.1 support for FAT32 file system. Last general purpose DOS to load Windows. MS-DOS 8.0, version 8.0 integrated drivers for faster Windows loading. 4 different kernels observed. Version 8.0 DOS boot disks created by XP and later contain files from Windows ME. The internal command prompt still reports version 5.0. Microsoft DOS was released through the OEM channel, until DRI released DOS 5.0 as a retail upgrade. With PCA DOS 5.00.1, the IBM-Microsoft agreement started to end, and IBM entered the retail DOS market with IBM DOS 5.00.1, 5.02, 6.00 and PCA DOS 6.1, 6.3, 7, 2007.1. Localized versions of MS-DOS existed for different markets. While Western issues of MS-DOS evolved around the same set of tools and drivers just with localized message languages and differing sets of supported codepages and keyboard layouts, some language versions were considerably different from Western issues and were adapted to run on localized PC hardware with additional BIOS services not available in Western PCs, support multiple hardware codepages for displays and printers, support DBCS, alternative input methods and graphics output. Affected issues include Japanese, Korean, Arabic, Hebrew, Russian as well as some other Eastern European versions of DOS. Competition. On microcomputers based on the Intel 8086 and 8088 processors, including the IBM PC and clones, the initial competition to the PCA DOS MS-DOS line came from Digital Research, whose CP/M operating system had inspired MS-DOS. In fact, there remains controversy as to whether QDOS was more or less plagiarized from early versions of CP/M code. Digital Research released CP/M86 a few months after MS-DOS, and it was offered as an alternative to MS-DOS and Microsoft's licensing requirements, but at a higher price. Executable programs for CP/M86 and MS-DOS were not interchangeable with each other. Many applications were sold in both MS-DOS and CP/M86 versions until MS-DOS became preponderant. MS-DOS originally supported the simple COM, which was modeled after a similar but binary incompatible format known from CP/M80. CP/M86 instead supported a relocatable format using the file extension CMD to avoid name conflicts with CP/M80 and MS-DOS COM files. MS-DOS version 2.0 added a more advanced relocatable exe executable file format. Most of the machines in the early days of MS-DOS had differing system architectures and there was a certain degree of incompatibility, and subsequently vendor lock-in. Users who began using MS-DOS with their machines were compelled to continue using the version customized for their hardware, or faced trying to get all of their proprietary hardware and software to work with the new system. In the business world, the 808X-based machines that MS-DOS was tied to faced competition from the Unix operating system, which ran on many different hardware architectures. Microsoft itself sold a version of Unix for the PC called Xenix. In the emerging world of home users, a variety of other computers based on various other processors were in serious competition with the IBM PC, the Apple II, early Apple Macintosh, the Commodore 64, and others did not use the 808X processor. Many 808X machines of different architectures used custom versions of MS-DOS. At first all these machines were in competition. In time the IBM PC hardware configuration became dominant in the 808X market as software written to communicate directly with the PC hardware without using standard operating system calls ran much faster, but on true PC compatibles only. Non-PC compatible 808X machines were too small a market to have fast software written for them alone, and the market remained open only for IBM PCs and machines that closely imitated their architecture, or running either a single version of MS-DOS compatible only with PCs, or the equivalent IBM PC ADOS. Most clones cost much less than IBM-branded machines of similar performance, and became widely used by home users, while IBM PCs had a large share of the business computer market. Microsoft and IBM together began what was intended as the follow-on to MS-DOS PC ADOS, called OS/2. When OS/2 was released in 1987, Microsoft began an advertising campaign announcing that DOS is dead, and stating that version 4 was the last full release. OS/2 was designed for efficient multitasking, an IBM speciality derived from deep experience with mainframe operating systems, and offered a number of advanced features that had been designed together with similar look and feel. It was seen as the legitimate heir to the kludgy DOS platform. MS-DOS had grown in spurts, with many significant features being taken or duplicated from Microsoft's other products and operating systems. MS-DOS also grew by incorporating, by direct licensing or feature duplicating, the functionality of tools and utilities developed by independent companies, such as Norton Utilities, PC Tools, QEMM Expanded Memory Manager, Stacker Disk Compression, and others. During the period when digital research was competing in the operating system market, some computers, like Amstrad PC 1512, were sold with floppy disks for two operating systems, MS-DOS and CP/M86 or a derivative of it. Digital Research produced DOS Plus, which was compatible with MS-DOS 2.11, supported CP/M86 programs, had additional features including multitasking, and could read and write disks in CP/M and MS-DOS format. While OS/2 was under protracted development, Digital Research released the MS-DOS-compatible DRA-DOS 5.0, which included features only available as third-party add-ons for MS-DOS. Unwilling to lose any portion of the market, Microsoft responded by announcing the pending release of MS-DOS 5.0 in May 1990. This effectively killed most DRA-DOS sales until the actual release of MS-DOS 5.0 in June 1991. Digital Research brought out DRA-DOS 6.0, which sold well until the pre-announcement of MS-DOS 6.0 again stifled the sales of DRA-DOS. Microsoft had been accused of carefully orchestrating leaks about future versions of MS-DOS in an attempt to create what in the industry is called FUD regarding DRA-DOS. For example, in October 1990, shortly after the release of DRA-DOS 5.0, and long before the eventual June 1991 release of MS-DOS 5.0, stories on feature enhancements in MS-DOS started to appear in InfoWorld and PC Week. Brad Silverberg, Vice President of Systems Software at Microsoft and General Manager of its Windows and MS-DOS business unit, wrote a forceful letter to PC Week, denying that Microsoft was engaged in FUD tactics and denying that Microsoft copied features from DRDOS. The feature enhancements of MS-DOS version 5.0 were decided and development was begun long before we heard about DRDOS 5.0. There will be some similar features. With 50 million MS-DOS users, it shouldn't be surprising that DRI has heard some of the same requests from customers that we have. The pact between Microsoft and IBM to promote OS/2 began to fall apart in 1990 when Windows 3.0 became a marketplace success. Much of Microsoft's further contributions to OS/2 also went into creating a third GUI replacement for DOS, Windows NT. IBM, which had already been developing the next version of OS/2, carried on development of the platform without Microsoft and sold it as the alternative to DOS and Windows. Legal issues. As a response to Digital Research's DRDOS 6.0, which bundled superseded disk compression, Microsoft opened negotiations with Stack Electronics, vendor of the most popular DOS disk compression tool, Stacker. In the due diligence process, Stack engineers had shown Microsoft part of the Stacker source code. Stack was unwilling to meet Microsoft's terms for licensing Stacker and withdrew from the negotiations. Microsoft chose to license Vertisoft's Double Disk, using it as the core for its double-space disk compression. MS-DOS 6.0 and 6.20 were released in 1993, both including the Microsoft double-space disk compression utility program. Stack successfully sued Microsoft for patent infringement regarding the compression algorithm used in double space. This resulted in the 1994 release of MS-DOS 6.2.1, which had disk compression removed. Shortly afterwards came version 6.2.2, with a new version of the disk compression system, Drive Space, which had a different compression algorithm to avoid the infringing code. Prior to 1995, Microsoft licensed MS-DOS to computer manufacturers under three types of agreement: per processor, per system, or per copy. The largest manufacturers used the per processor arrangement, which had the lowest fee. This arrangement made it expensive for the large manufacturers to migrate to any other operating system, such as DRDOS. In 1991, the U.S. government Federal Trade Commission began investigating Microsoft's licensing procedures, resulting in a 1994 settlement agreement limiting Microsoft to per-copy licensing. Digital Research did not gain by this settlement, and years later its successor in interest, Caldera, sued Microsoft for damages in the Caldera v. Microsoft lawsuit. It was believed that the settlement ran in the order of $150 million, but was revealed in November 2009 with the release of the settlement agreement to be $280 million. Use of undocumented APIs. Microsoft also used a variety of tactics in MS-DOS and several of their applications and development tools that, while operating perfectly when running on genuine MS-DOS, would break when run on another vendor's implementation of DOS. Notable examples of this practice included, Microsoft's Quick Pascal released in early 1989 was the first MIS product that checked for MS-DOS by modifying the program's program segment prefix using undocumented DOS functions, and then checked whether or not the associated value changed in a fixed position within a DOS data segment. This check also made it into later MIS products, including Microsoft Quick CV 2.5, Programmer's Workbench and Microsoft CV 6.0. The AARD code, a block of code in the Windows 3.1 beta installer. It was XOR encrypted, self-modifying, and deliberately obfuscated, using various undocumented DOS structures and functions to determine whether or not Windows really was running on MS-DOS. Note that the Windows 3.0 beta code only gave a warning that Windows would not operate properly on a foreign OS. It did in fact run just fine on DRDOS 6.0. Interrupt routines called by Windows to inform MS-DOS that Windows is starting exiting, information that MS-DOS retained an in Windows flag, in spite of the fact that MS-DOS and Windows were supposed to be two separate products. And of MS-DOS. Since the release of Windows 95 up until Windows NT, it was segregated as a full product used for bootstrapping, troubleshooting, and backwards compatibility with old DOS games and no longer released as a standalone product. Windows XP contains a copy of the Windows ME boot disk, stripped down to bootstrap only. This is accessible only by formatting a floppy as an MS-DOS startup disk. Files like the driver for the CD-ROM support were deleted from the Windows ME boot disk and the startup files no longer had content. This modified disk was the base for creating the MS-DOS image for Windows XP. Some of the deleted files can be recovered with an undelete tool. With Windows Vista, the files on the startup disk are dated April 18, 2005 but are otherwise unchanged, including the string MS-DOS version 8 to copyright 1981 €1999 Microsoft Corporation inside command.com. However, the only versions of MS-DOS currently recognized as standalone OSs, and supported as such by Microsoft are MS-DOS 6.0 and 6.2.2, both of which remain available for download via their MSDN, volume license, and OEM license partner websites, for customers with valid login credentials. MS-DOS is still used in embedded x86 systems due to its simple architecture and minimal memory and processor requirements. The command line interpreter of NT-based versions of Windows, Commander EXE, maintains most of the same commands and some compatibility with DOS batch files. Windows Command Line Interface. All versions of Microsoft Windows have had an MS-DOS-like command line interface. This could run many DOS and variously Win32, OS/21X and POSIX command line utilities in the same command line session, allowing piping between commands. The user interface, and the icon up to Windows 2000, followed the native MS-DOS interface. The 16-bit versions of Windows ran as a graphical user interface on top of MS-DOS. With Windows 95, 98, 98 SE and ME, the MS-DOS part was integrated, treating both operating systems as a complete package. The command line accessed the DOS command line, through a Windows module. A new line of Windows boot through a kernel whose sole purpose is to load Windows. One cannot run Win32 applications in the loader system in the manner that OS/2, Unix or consumer Windows can launch character mode sessions. The command session permits running of various supported command line utilities from Win32, MS-DOS, OS/21X and POSIX. The emulators for MS-DOS, OS/2 and POSIX use the hosts window in the same way that Win16 applications use the Win32 Explorer. Using the hosts window allows one to pipe output between emulations. The MS-DOS emulation is done through the NTVDM. This is a modified soft PC, running a modified MS-DOS 5. The output is handled by the console DLLs, so that the program at the prompt can see the output. 64-bit Windows does not have either the DOS emulation, or the DOS commands, that come with 32-bit Windows. The DOS version returns 5.00 or 5.50, depending on which API function is used to determine it. Utilities from MS-DOS 5.00 run in this emulation without modification. The very early beta programs of NT show MS-DOS 30.00. But programs running in MS-DOS 30.00 would assume that OS/2 was in control. The OS/2 emulation is handled through OS/2SX and OS/2EXE, underscores DLL. OS/2EXE is a version of the OS/2 shell, which passes commands down to the OS/2SX, and input-output to the Windows NT shell. Windows 2000 was the last version of NT to support OS/2. The emulation is OS/2 1.30. POSIX is emulated through the POSIX shell, but no emulated shell. The commands are handled directly in Commander EXE. The command prompt is often called the MS-DOS prompt. In part, this was the official name for it in Windows 9X and early versions of Windows NT, and in part because the soft PC emulation of DOS redirects outputs into it. Actually only command.com and other 16-bit commands run in an NTVDM with autoexec NT and config NT initialization determined by default PIF, optionally permitting the use of Win32 console applications and internal commands with the NTCMD-PROMPT directive. Win32 console applications use Commander exe as their command prompt shell. This confusion does not exist under OS/2 because there are separate DOS and OS/2 prompts, and running a DOS program under OS/2 will launch a separate DOS window to run the application. All versions of Windows for x86-64 and Titanium architectures no longer include the NTVDM and can therefore no longer natively run MS-DOS or 16-bit Windows applications. There are alternatives in the form of virtual machine emulators such as Microsoft's own Virtual PC, as well as VMware, DOSBox, and others. Legacy compatibility. From 1983 onwards, various companies worked on graphical user interfaces capable of running on PC hardware. With DOS being the dominant operating system, several companies released alternate shells, for example Microsoft Word for DOS, Xtree, and the Norton Commander. However, this required duplication of effort and did not provide much consistency in interface design. Later, in 1985, Microsoft Windows was released as Microsoft's first attempt at providing a consistent user interface. The early versions of Windows ran on top of MS-DOS and its clones. At first Windows met with little success, but this was also true for most other companies' efforts as well, for example GM. After version 3.0, Windows gained market acceptance. Windows 9X used the DOS boot process to launch into protected mode. Basic features related to the file system, such as long file names, were only available to DOS when running as a subsystem of Windows. Windows NT runs independently of DOS but includes NTVDM, a component for simulating a DOS environment for legacy applications. Related systems. Several similar products were produced by other companies. In the case of PCA-DOS and RA-DOS, it is common but incorrect to call these clones. Given that Microsoft manufactured PCA-DOS for IBM, PCA-DOS and MS-DOS were identical twins that diverged only in adulthood and eventually became quite different products. Although DRA-DOS is regarded as a clone of MS-DOS, the DRA-DOS versions appeared months and years before Microsoft's products. What made the difference in the end was Microsoft's control of the Windows platform and their programming practices, which intentionally made Windows appear as if it ran poorly on competing versions of DOS. DRI had to release interim releases to circumvent Windows limitations inserted artificially, designed specifically to provide Microsoft with an unfair competitive advantage. PCA-DOS, DRA-DOS/Novella-DOS/OpenDOS, GNU-DOS/FreeDOS, PTS-DOS, ROM-DOS. These products are collectively referred to as DOS. However, MS-DOS can be a generic reference to DOS on IBM PC compatible computers. See also, for DOS a Euro designed to replace the default command interpreter command.com, bad command or file name, comparison of DOS operating systems, DOSBox, DOSKey, MS-DOS utility, history of Microsoft Windows, list of DOS commands, list of Microsoft Windows versions, list of MS-DOS games, Microsoft Windows, MS-DOS API, TauXDOS a Euro commercial solution for DOS software on new Windows systems. Timeline of DOS operating systems, Win32 console a Euro a text rendering system akin to MS-DOS, references. External links, MS-DOS source, MS-DOS 1.1 and MS-DOS 2.0 source code at Computer History Museum, MS-DOS overview, on Microsoft website, current license agreement policies for MS-DOS and Windows, Tim Patterson on DOS a Euro Patterson wrote the QDOS OS, Richard Bonner's DOS website, BAT files the DOS Batch File Programming Handbook and Tutorial, Arachne Graphical Browser for DOS, Linux DOSMU, Rolf Brown's Interrupt List, DOSBox, a multi-platform DOS emulator, Garbo an MS-DOS program distribution library at the University of Vaasa, Finland, MS-DOS 6 technical reference at Microsoft TechNet, promotional video for MS-DOS 5. Testing MS-DOS limitations.